Okay, so now we're going to look at angles of elevation and depression. Now, once again, we'll still be using trigonometry in order to calculate our knowns in this situation. However, these are just particular angles, especially when it comes to navigation and bearings, etc. We would hear these words quite a bit. Now, what you need to remember is angles of elevation and depression are always measured from the horizontal. So, looking down or up. This here is elevation. This down here, depression. Now I kind of remember by sort of going, I go up in an elevator, you know, or when I feel really up, I'm in an elevated mood. And depression, look, feeling down, depressed. Even if you remember this one, it will mean that elevation is the other, it means up. So what's important to note is that if this is my eye, here's my cool little eye. Yeah, that's an eye. Don't get judgy. Here's my eyelashes. Okay, there's my eye. Now, if I am looking upwards, it is measured from the horizontal. So this is my angle of elevation, okay, in here. If I am looking from the horizontal down, then this is my angle of depression. Now, it is really important that you remember that. So, if I were to, let's draw a tree. Here is my tree. And in my tree, I have this bird with a really, really strange body and weird little legs. And he has a little tail. And here's his little wing. There we go. Give him a little eye. Beautiful. Okay, down here, I've got a puppy dog. Oh, actually, let's make him a cat. Mostly because I probably can't even really draw a cat either. There, give him two little arms. It is terrible. Little nose, some whiskers, and eyes, and then let's give him some ears. There we go. A cat. No judging of my drawings. Okay, now, if my cat was looking up at the bird and my bird was looking down at the cat. So basically, this is where my cat is looking. And this is his eye level. So it's always measured from, if this is my eye level, and then I look up. So I'm measuring from eye level, horizontal eye level, up. Or I'm looking horizontal eye level and then I measure down. It's really important that you understand the difference. So this would be my angle of elevation. So you can see I draw up, I'm looking up. That would be the angle. For my bird, however, he's looking down along this same trajectory. However, his eye level is here. And so his angle will be measured down this way. So he will have an angle of depression. The cat will have an angle of elevation. Okay, so what I want to do now is just go through a couple of examples. They're going to be word ones, so I'm just going to write them up. Okay, so a circus ringmaster is holding an 18-meter long rope at eye level that is attached to the top of a tent pole. He calculates the angle of elevation as 35 degrees. What is the height of the tent pole? Okay, so here is my ringmaster. And here is his cool ringmaster top hat. Okay, from there we've got a nice tall tent pole, and he is holding this rope at eye level to the top here of this tent pole. There's his eye level. That makes it a right angle, yeah? So I end up with a lovely right angle triangle that I'm just going to draw over the side here. Okay, Now, it says the angle of elevation is 35 degrees. So this is 35 degrees. Elevation from the horizontal up. And the rope is 18 meters long. So this is 18 meters. I want to know the height of the tent pole. Okay, so if this is my triangle, then this is 35 degrees. This is 18 meters. And this is X. What I can look at is, this is my angle, so this is going to be the opposite side. This is the hypotenuse, clearly, it's the longer side, and that means this is the adjacent side. So from here I can calculate using trigonometry. So Sohcahtoa, I have the angle, so SC and T, and I have the hypotenuse. Oh, that doesn't work. I have to actually write toa. Sohcahtoa. Okay, I need to find opposite. That's my X, so I put a little dot for opposite, and I don't have adjacent, so I cross adjacent. So the only one that has 2 ticks and a dot is sine. So sine of the unknown angle will be opposite over hypotenuse. Sine of the angle is 35 degrees is going to be opposite unknown, so X, and the hypotenuse 18. So if I'm dividing by 18 here, if I multiply by 18, that gets rid of that and leaves X, and I multiply by 18 on this side, in order to get, I just go sine 35 multiplied by 18, and I get 10.32 thereabout meters. It kind of continues, so I can put X on this side and say X is approximately 10.32 meters. Now here's my problem. What I have actually figured out is this distance here. So what I can say in my therefore statement in order to make it correct is I can say that the height of the tent pole is approximately, height of the tent pole is about 10.32 meters plus the height of the ringmaster's eyes from the ground. Because the tent pole is not sitting up at eye level. Okay, the tent pole doesn't sit up here at eye level and just be this amount. But when we draw that triangle, it's really important to note, you're just finding this distance from eye level to the top of the pole. You actually need to still add in however high the ringmaster's eyes are from the ground to get your answer. Okay, so now I'm just going to clear off and we'll do one more word problem. Okay, so the angle of depression of a ship from the top of a 220 meter vertical cliff is 28 degrees. There, oh, I've actually written that wrong, haven't I? To the nearest meter. To the nearest meter. How far is the ship from the base of the cliff? Let's draw it out. So that's our first thing. So here is my cliff, straight down. So it says a vertical cliff. And here is my water. Out in the water is my boat or ship. That's my ship. Yes. Okay, so what do I know? I know that if I'm going from my ship to the top of the vertical, this is, actually it probably should be a dotted line, shouldn't it? That would make it a bit easier to understand the diagram. So let's just make that dotted. So this is what I'm looking at. I'm looking at the ship. I know that it's 220 meters, this cliff. Okay, so from top to bottom, 220 meters. And I know that the angle of depression is 28 degrees. So what that tells me is, remember that the angle of depression is from the horizontal. That's my dot there. That means this is 28 degrees. Okay, it is always from the horizontal down. So if I'm going from the ship, it's looking down. That's my angle of depression. Now what I can do is I can use my Z rule. So my parallel line rules say, my Z rule is that this one, alternate angles equal. So that means, I see how I can draw a Z here backwards like that. That means that this angle and this angle are identical. So this angle and this one will also be 28, and that's because these are parallel lines, both of them horizontal. So what that means is I can draw my triangle. It's a right angle. This is 220 meters, this side. And I know now that this is 28 degrees. I do not know anything else except that I need to know how far is the ship from the base of the cliff. This is the base and this is the ship. So I'm finding this distance along the bottom. Okay, so seems fairly straightforward. Let's work this one out. Okay, if this is my known angle, then this is the opposite side. This is clearly my hypotenuse, and that makes this one the adjacent next to the angle. So over here I'm going to write Sohcahtoa so I can figure it out. I have an angle, tick for S, C and T. I have opposite, tick the O's. I need to find adjacent, so I'm going to put a little dot over the A's. I do not have a hypotenuse, cross those. So the only one with two ticks and a dot is tan. So I write my rule. Opposite over adjacent. Okay, so I do have an angle, so I can sub in my unknown angle for 28 degrees. My opposite is 220, but I don't know my adjacent. Oh, actually, but in the diagram it's labeled as X. So remember, if I'm dividing by X, I can't just multiply. I'm not dividing by 220, I'm dividing by X. And while I want to get it on its own, the first thing I have to do is I have to multiply by X on both sides. So that means I put it over here where I multiply. That just gets rid of it here. Then, now that I'm multiplying X multiplied by tangent 28, I can divide by the tan of 28 degrees. So when I do that, I end up with 413.76, and it continues on. So because it actually says to the nearest meter, I'm going to say that I'm 414. That 0.76 just tells me to round up. So I am 414 meters. So therefore, the ship is 414 meters from the base of the cliff. Bell. Okay, so remembering that for all of these word problems, our diagrams net us our M1, they net us C1 when we're looking at using the correct symbols and terminology on these diagrams. They give us C2, presentation organization, so I can see, figure out what you've done. C3, translation of information from written to diagrammatic to algebraic, and being able to do that correctly. That's C3. I've got K1 for my rule. I've got K2, all of my subbing and calculating as we go. And then I've got K3, actually calculating using a calculator. Our M3, which I gave verbally here and I wrote over here, is our informed decision. Remembering in our circus ringmaster situation that we actually had to think contextually about the fact that we could not find the rest of the flagpole, so we had to indicate that the height would also be, it would be the amount that we worked out plus the height of the ringmaster to his eyes from the ground. And this is where all your criteria will be picked up for in your exam. So make sure that you're comfortable with angles of elevation and depression, remembering that while we may have found some missing sides and distances in these problems, sometimes you are actually asked to find the angle of elevation or the angle of depression. What you need to look out for in these questions, and you can use trigonometry to do that, but what you need to look out for is to make sure that you are correctly drawing your diagram from the information given. Okay, so don't make this an angle of depression. Angles of elevation and depression are always measured from the horizontal. So it's important that you actually identify correctly where those are.